box. This one goes for the box, so it will take 8 bytes every object, and this only takes 4. Yeah. So anyway, the first one, the first thing I want to do is to profile our browser with that. And then basically, if I have no idea, you can just use a gateway profile. That's the point here. And you can take a look at the stack, and the interesting thing is that you cannot see the full stack because the JIT will make some jumping from your stack. So when it puts something inside an assembly address and directly execute that, you cannot see the whole stack. So it makes the debugging more difficult. And the thing I can see is that when it does so much times, the minor GEC will hit the count as maybe, I think it's only 9,000 times. So there must be something missing. The code, the function code must be missing in the stack. So I think I thought that I need to find out the reason. But I want to time in the whole page first because there are a lot of factors. So the first thing is the JIT passing time because the JIT need to pass the bytecode to the graph. For example, in the iMonkey. And maybe it do too heavy optimization for that code. Or maybe the assembly generated is in phasing. And maybe there are too much data. So I need to examine these ideas first. So the basic idea is that I just need to measure all the time between the state by state. But the final result is horrible because I can print a lot of logs, but it's too detailed, so I cannot find any useful group. And I even do some statistics to make it a graph, but again, it's not useful. So basically, it's a failure. Yeah. But I think I learned something about that is that basically the baseline, the iMonkey works well. So the problem is not in the two JIT engines. And it shows that how mirror get compiled and generated and deprecated.
What? I don't know if this idea would work, but since the functions are similar,
yeah.
Like the only difference is one has properties, one doesn't, couldn't you do something like you run both the code and then you compare like the function calls, do like a diff of the trees that are created?
Yeah, but the point is there are something missing inside assembly because it will not show up as a C part stack. Okay. So I cannot see that part, and that part actually does the different. Did the different. Okay. So if anyone knows how to ensure the whole C++ code base include the assembly part, please tell me. I need that. Yeah. And the next one is I need to examine whether the assembly and the beta are too many and embedded. So remember that we have a step from baseline to IM, and there's a graph named mirror. So before we jump into the assembly, we can take a look at the IM graph here. It's a tool to print how it looks like for the mirror graph looks like for your JavaScript code. And you can see the whole code flow here and the block. The basic block. For example, this block is the constructor of our class. The one with 2 members. And actually, one graph can include 28 steps, for there will be 28 picture files per graph. Like this. So it will indicate you that there's so much places for one graph. And if you want to print more about the JIT activities, you can use these flags when you are running our browser or the JavaScript engine. standalone. So because of this log, I can see something here like the iMonkey take the bailout here, because the script it compiled it is now embedded. So you need to use the git spell and with the graph. But well, that's not enough for tracing the issue, because it seems that the iMonkey will generate two graphs for one line, the first line of the script. So I don't know how to explain that why we need multiple graphs for the same line. So we have a map untraceable, and the problems are here that the first thing is that the multiple graph for the same line I mentioned. And then the bailout and reentry, because I didn't know how the iMonkey follow the flow and where the bailout is. And we have not too much document on our development network and the comments. So that's the little problem. So you can ask someone on our IRC, of course. Yeah, and someone will reply you.
不好意思，有点迷失。那个说同行啊会有两种 IR trees 的原因是？
你说
对这边对这个原因是？
这个我后来问到的原因是因为，当你比如说你 iMonkey 执行到这边，假设到这边好，它被绕，因为有些猜测错，它会被烧，后面整张图都会被退掉，所以它会再试图重新产生到7。 再同一行。
So your optimization is not deterministic because some kind of error.
对，这不可能 deterministic， 因为 Git 是边做边 optimization。
I see.
那如果它是一个传统 compile， 应该就会发生。
I see. Thank you.
Okay. Although the graph doesn't help, but at least I can make sure that the flow is correct. The flow generated and optimized by iMonkey is correct. So I got puzzled again. And if you take a look at the GDB or LDB state, you can see there's a horrible empty line here. It shows nothing but the git frame enter and EC. So when you step inside these two lines, it will tell you some assembly, and I cannot read this. So I got puzzled again.
Yeah.
So it's good now. And basically, you need a data console log or primitive, and try to collect everything you can. And after doing that crazily, I finally got something. So basically, I find that this line means it enters the loop and ends the iteration without trigger some C process method. So for example, this line is called in the git frame, so it's in assembly, and I cannot trace that. But sometimes it will stop at the C process method. So I find that this constructor with two members will trigger that C process method every such number of iterations, and this one is triggered sooner. So it also hints that the line is about the minor GC. So the next topic is about our GC. And basically, this is a very stupid way to debug the program. You just print out logs and put the program inside the debugger and press N to make it step over the line again and again to find something you can use. But it works. So basically, according to the result, I found that because I know we have a area in memory named nursery. When the nursery is full, means it needs to trigger the minor GC to clean the nursery to put more object inside. So I got some clue here. So it shows that the empty constructor without members will fill the nursery faster. That's the issue. And it also means that the objects from the empty constructor is more fat than the one with two members. So it's very strange. So about our GC. Okay, I will introduce some quick fact about generational GC because inside the SpiderMonkey we use generational GC as our GC model. Yeah. This is from the Java, the IBM script, so I just borrowed it. But anyway, it explains the whole generational GC very well. So basically, in a generational GC engine, it will split your memory into two parts. One is the old area and one is nursery. And the nursery will be split again. One is named allocated space and one is survivor space. So when you have some objects like an array or a variable with some data not on the stack but on the heap, the GC engine will allocate the object in the area of nursery. And when the nursery full, it needs to do the minor GC, means it will not clean all the area but only the nursery. So when the minor GC happens, it will try to tracing each object on in the nursery and try to find if someone is using it or not. So if there is no root object referred to such object, it will be clean. Yeah. So that's how minor GC and the generational GC work. Because it's called generational because when objects be referred to long, it will be moved to another ternary space. Yeah. So inside this space, it will be collected later, much later than the nursery. Because the assumption is that 90% new objects will be deprecated at the first round of GC. So we can only we can do that better when we just clean the nursery. Yeah.
Does the engine keep a format for an object and who is reference to this object?
Sorry.
There
is a root.
So the tracing is begin from the root or
from the root. From the root. This is some root object and it will refer to another object. So when the reference is disconnected, the left object will be clean in the next one.
So the GC style it will trace from the root, so it will trace the whole memory. Not only those.
The memory the engine allocated. Yeah, you can adjust such config in your browser. Yeah. So for example, I saw the config for the GC now is basically 32 megabytes. Okay, it's an overview of generational GC and it also used inside the SpiderMonkey. So what happened when it failed out? Basically, the iMonkey will try to make some object template in assembly. So when it allocated the new object, it will not refer the constructor again, but copy the template. So it is much quicker. It's much quickly than to refer the original constructor. And the object will fill nursery fast. So when the nursery is full, the water stopped, and then it will call a CPUB method, and this is very slow, about 2 microseconds. And then it will bail out to non-JIT code, namely to interpret to trigger minor GC and recreate the object template again. So it's very slow. So when one loop runs faster means it created the object in a small size. So it fills the nursery slower. Okay. So why there's such difference is because when your class is with empty constructor, the engine doesn't know how much memory it will be with, so it needs to give a very general guessing. So it's 8 bytes for the 64 bits machine. But when you assign two members inside your constructor, the engine knows you will have at least two members of your class and the object. So they can shrink the size of the object to 4 bytes. So it's a very huge difference here. And then, so I recommend if you write front-end code, you may try to put your own known members inside constructor rather than put it later. It may boost your program, especially if your program has a lot of new objects. It's a micro optimization, but it will be useful because from engine side to do that.
But what happens? Can the properties be attached to a constructor with some members? Did that happen?
That will follow another complicated path to make the layout raw. Yeah, and it will not related to this case.
But if that is the case, why wouldn't a empty constructor be just created empty and then grow out later?
Yeah, I think I asked someone. They said that this is a heuristic guessing about how to optimize this case. So the 8 bytes is main artificial choice. Yeah. So maybe we can use it as a 0 bytes. Yeah, but maybe there will be make some website slow down because usually it will not be 0 a constructor. Yeah. Okay. So we have solved the issue by we find out the root cause of such issue, but basically the thing I learned is the auto printf. Means we cannot find anything useful. You just print everything and try to get it in debug mode.
So is this really a bug?
Yeah, this bug you can see comment, and we haven't had any page follow-up because someone said that we need to make sure all the modern frameworks in the website to make sure the next heuristic algorithm works. Yeah, so we didn't have the conclusion. Okay, so that's my last case and the end of the slide. So let me conclude. The first section of my slide introduced an overview of our JavaScript engine, and the next one is for the JIT part because it's the most important part inside our engine for the performance. And then I introduced the bug here for the case that the empty constructor in the loop will slow down the program compared to the one with members. And then I introduced one tool useful for basically any case that you don't have any idea. And then next one is how I solve the issue, or how I find out the root cause of the issue by some lucky guessing. Yeah, here. Okay, so that's all. Any question?
How do you guys handle code quality?
We have a reviewing system. Every page, even if it's only one CSS line, it needs to be reviewed before landing.
Okay.
So that's why we can keep the basic code quality. But sometimes you can see some nasty code inside code base. That means some reviewer and the committer. So you feel, yeah.
Are you doing any sort of like unit testing or anything like that? Or?
That's an interesting part. When we developed our Firefox OS phone, the front-end part, that means the application part, we have unit tests for all apps.
Yeah.
But the Gecko and the SpiderMonkey, they barely have the unit tests because it's already too many.
Yeah.
So you run it will take, I think it's 13 minutes.
Yeah.
So that's ridiculous, but that's the reason I heard of about why we don't run and write unit tests for every page. Yeah. Yeah, so that's how we keep the
practice it.
code.
Do you still practice in your test? I think a lot
Well,
of
we do, I guess, test-driven development, but we're doing Haskell, so
Yeah,
it's a lot
it's a
nicer.
fantastic tool.
This one, this, I've been so long since I've seen C++, it's scary.
Yeah, and time system will stop you from doing something really
Right.
stupid.
Yeah.
Instead you use any and unsafe. Yeah. Okay. Then and any other question?
I've got one question about the baseline JIT. So you've mentioned that before the baseline JIT there is a bytecode interpreter that calls the C++ generic code.
Yeah.
And now when it gets to the baseline JIT, does it start from the JavaScript source code, or does it start from the bytecode?
It will start from the bytecode.
So it is JITting from the bytecode.
Yeah. I can let's see if I can find out the layer future. Here. In this one. So yeah.
For example, when looking at the bytecode, it looks something like there's a very small virtual machine, and the bytecode maybe just be some instruction like loading a value from the stack.
Yeah.
So is the bytecode things like this?
Basically, bytecode is actually I can demo.
Or say, how does the later JIT recover the whole computer structure from the? Does they recover the computer structure from the bytecode, or I mean, maybe the bytecode has something like jump to the third line or branching, or is it a structure like a tree, or is it just?
The bytecode is more like an assembly.
So it's
so
straight.
there's a jumping instruction inside. As so you can see the it called OP code actually. You can search for the spider monkey OP code, and it will show you the bytecode. So here. So you can see all the bytecode here. Like we have go to.
Oh.
And if you EQ, just like the CPU instruction.
So the Iron Monkey really just does some hard work to recover that graph from this sort of bytecode.
Yeah, but it's a very low level graph compared to your program. Okay. Any other question? Okay, maybe we can discuss later in the. We finish it. Thanks for everyone. Yeah.
问一下，然后你先买。